Let's learn about the basic operating structure and characteristics of each type of diode, the most basic semiconductor device. The diode component has a p-n junction structure. The p-type semiconductor side is called the anode, and the n-type semiconductor side is called the cathode. It allows current to flow only from the anode to the cathode, and does not allow current to flow in the opposite direction. In other words, it is a device that allows current to flow only in one direction, and is used for rectification, switching, etc. In the symbol, the triangular part is the anode, the vertical bar part is the cathode, and just like the diode symbol, current only flows in the direction of the arrow and is blocked in the opposite direction of the arrow. In order for a diode to conduct and allow current to flow, a positive voltage must be applied to the P side and a negative voltage must be applied to the N side. This biasing is called forward bias and the diode is turned on. Conversely, if biased, the current is blocked and it becomes reverse biased and the diode is turned off. When the diode is forward biased and turned on, a voltage drop of about 0.7 volts occurs between the P and N sides, and this forward voltage drop is called VF. In order to reduce power loss, the lower this forward voltage drop VF is, the better. To intuitively understand the operation of a diode, you can think of it as a structure of a drain pipe's blocking bar. In forward bias, the blocking bar is opened by voltage, i.e. water pressure, allowing current to flow. In reverse bias, the blocking bar is caught in the latch by voltage, i.e. water pressure, preventing current from flowing. In this way, the operating structure of a diode can be summarized in one word as a unidirectional current switch. Diodes are classified by function according to the application circuit, by current capacity, and by size or package shape. According to the classification by the function or operating characteristics of the diode. Rectifier diodes for converting alternating current to direct current are divided into general rectification for low frequency and high frequency high-speed rectification, and switching diodes for turning on and off power or signals. Schottky barrier diodes that can reduce power loss due to low forward turn-on voltage, i.e. voltage drop VF, constant voltage diodes. Also known as Zener diodes, for supplying constant voltage to the circuit, and detector diodes used for high frequency, i.e. RF signal bands, and PIN diodes for RF signal switching. In addition, LEDs that emit light of various colors and TVS that prevent circuit loss due to high voltage or static electricity are also included as types of diodes. But since there are many specific details to cover, we will cover them as a separate topic. Diodes are classified by the size of the forward current, or IF, that they can handle. Generally, diodes for less than 1 ampere are called small signal diodes, and diodes for more than 1 ampere are called power diodes. Depending on the diode's package and mounting style, it is divided into leaded, or dip or axial, types and surface-mounted, or SMD, types. Leaded types generally have large capacities, but recently, as the range of applications for SMD types has expanded, many large capacity types have been released and are being used. The rectifier diode is a diode that converts alternating current into pulsating current, as its name suggests. The purpose of rectification is to change alternating current into direct current in order to change it into pulsating current, and it has the characteristics of high voltage and high current. In addition, considering the power efficiency according to the usage frequency or conditions, there are various types such as low forward voltage diodes and high-speed switching diodes. These rectifier diodes are mainly applied in power circuits, and therefore are divided into classical rectifier diodes used in commercial power supplies of 50 or 60 ohms as power diodes of 1 ampere or more, and high-speed rectifier diodes used in high frequencies of tens of kilohertz or more, such as SMPS. Switching diodes are mainly used for purposes such as selectively supplying power, clipping to cut a specific signal level, and clamping to fix the DC level of the signal. Most of them are used for switching purposes such as selectively supplying power sources. For example, if 5 volts are supplied to the MCU and the USB power is turned off, the battery voltage must be continuously supplied. In other words, when 5 volts of USB power is applied, power is supplied through the path of diode D1, and at this time, D2 is turned off. And when 5 volts of USB power is not supplied, the battery voltage of 3 volts is supplied through the path of diode D2. This is how the power supply path can be selectively switched. This circuit is a circuit for preventing the use of real-time clocks or loss of internal essential storage information in the MCU circuit. These switching diodes can use Schottky diodes to reduce voltage drop, but since Schottky diodes have relatively large reverse currents, it is necessary to check the reverse current characteristics on the datasheet, and a diode with a low reverse current characteristic should be applied if possible. While general diodes have diode characteristics due to the p-n junction structure, Schottky barrier diodes are diodes that utilize Schottky barrier characteristics that occur due to the junction between metal and semiconductor. Compared to general p-n junction diodes, it has the advantage of low forward voltage, VF, and fast switching characteristics. However, since the reverse current IR is large, a design that takes this into account is required. Because it has low forward voltage, VF, and excellent switching characteristics, it is widely used for secondary rectification of SMPS power supplies that require high-efficiency design, or for switching of DC-DC converters. Since the reverse current IR is large, there is a concern about thermal runaway due to the increase in leakage current, so a design that takes heat dissipation into account is required in large current circuits. While general diodes are used in the forward direction, the Zener diode has the characteristic of being used in the reverse direction, and due to its characteristic of maintaining a constant voltage, VZ voltage, for a reverse voltage higher than the Zener voltage VZ, it is used as a protection element to protect the circuit from constant voltage circuits, surge current, and static electricity. The breakdown voltage in the reverse direction is called the Zener voltage, VZ, and the current at this time is called the Zener current, IZ. The Zener current, IZ, which is the standard for the reverse voltage, VZ, ranges from 0.05 mA to 20 mA, so you should refer to the datasheet depending on the Zener diode when designing. Recently, with the high integration and high functionality of electronic products, even higher performance protection devices are required. Therefore, TVS, or transient voltage suppressor, is generally used more than Zener for static electricity or surge protection, and in constant voltage circuits. Zener diodes have a lot of power loss due to Zener current for maintaining constant voltage, so dedicated voltage regulators or LDOs are mainly used. High-frequency diodes are divided into detector diodes used for RF signals and PIN diodes for switching purposes. PIN diodes are mainly used for switching RF signals, attenuators, AGC circuits, etc. Looking at the switching action of RF signals, in the circuit on the right, when the V bias is high, the PIN diode turns on, and when it is low, it turns off. A PIN diode, as the name PIN itself suggests, is a high-frequency diode with an intrinsic semiconductor region between the p-type semiconductor and n-type semiconductor regions. Let's learn about the electrical characteristics of diodes. The forward voltage, VF, is the turn-on voltage of the diode in the forward bias state. It is around 0.7 volts for a general diode and less than 0.5 volts for a Schottky barrier diode. The reverse current, IR, is the current that flows in the reverse bias state and is small, less than tens of microamperes. The maximum reverse voltage, VR, is the maximum voltage that can be applied in the reverse direction. And the breakdown voltage is the voltage at which the diode breaks down when the reverse bias voltage is too high. The maximum reverse voltage is set to be 5 to 10% lower than the breakdown voltage. Reverse recovery time is the time it takes for the diode to go from the on state to the completely off state. When the diode is on and then off, since the moving electrons cannot suddenly stop, a certain amount of reverse current will flow. The larger this value, the greater the loss. For applications that require high-speed switching, a fast recovery diode, or FRD, with a short reverse recovery time, TRR, is applied. When the diode is reverse biased, an electrical neutral layer is created between the p-n junctions, and it has capacitance characteristics. This value is called the electrostatic capacitance, CT. It is usually less than several tens of picofarads. In high-speed switching circuits, a diode with a small cord is suitable because a large CT causes waveform distortion due to the capacitor effect. General semiconductor devices are divided into maximum ratings and general ratings. The maximum rating means a condition that must not be exceeded even once. If the maximum rating is exceeded, there is a possibility of failure or damage, and even if it operates normally immediately thereafter, the lifespan is shortened due to impact. So it must be designed so as not to exceed the maximum rating. Thank you. Bye.